Hello and welcome to the final oral presentation for Team B23, Assistive Camera Control. My name is Michael Makta, and with me are my fellow team members who will all be speaking throughout the presentation. My team members are Blake Van Neal, Nathan Suka, Nicholas Claxton, and Will Yeoman.
The overall goal of our project was to design an assistive camera control device that is durable and easy to use, with a deadline and a budget of May 2020 and $1,500 respectively.
Our client, Gary McDermott, is a C5 quadriplegic war veteran with a passion for photography. Quadriplegics can have varying levels of movement, but in Gary's case, he does not have any movement below the elbow and must lift his arms and then rely on gravity to lower them. For this reason, it is not possible for him to operate his camera through the shutter button alone. Gary has had numerous bite switches in the past, but all of them continue to fail due to normal wear and tear where the bite switch is bitten. As a result, we are looking for a better and more durable solution. Gary has also expressed interest in adding more features such as zoom if that were possible. Hopefully with our help, Gary will be able to continue to pursue his passion for photography.
Moving on to customer needs, the top 5 most important customer needs are shown in the chart. The most important customer needs include that the device must be hands-free and be able to trigger the camera shutter so that our client can use our device to take a photo with his specific digital camera. Furthermore, the device must also work independent of a caregiver so that our client can have the freedom to pursue photography on his own. Lastly, the device must be durable for long-term use and must be safe to use inside the mouth.
The final design of our project has evolved throughout this year. Change was made as our team determined new ways to best meet our target specifications while making up for lost development time and resources. At our client's request, we have developed 2 options for controlling his camera. The first prototype we developed was modeled after the prior art Peregrine bite switch. We wanted to give Gary a simple, durable, and functional option. The bite switch functions by simply being Velcro strapped onto his wheelchair headrest and plugged into his already mounted camera on his mountain mover platform. The device itself is a simple circuit that switches resistive loads based on the state of the binary switch. The circuit is soldered together in line so that no PCB was necessary, and so would be nearly undetected within the tubing. As mentioned, this design was a previous device Gary had. However, we attempted to design it in a more durable fashion for longer-term use and safer use. This was done by using heat shrink, tubing, and ample solder to make smooth joints for the electrical components so that they would not break over time as his previous devices had. This device is being shipped to our client with instructions for use to ensure it lasts as long as possible. In addition, our second prototype we developed was a blow switch version. The blow switch operates on the same circuit as the bite switch, but with a larger triggering mechanism. For this reason, we had to design a small case to be mounted somewhere on Gary's wheelchair by way of Velcro, 3M adhesive, or screw hole. The blow switch differs in that only a small puff of air will shutter the camera. This makes it physically less taxing on the user than the bite switch and provides a more long-term, durable build. The tubing is a connector for an interchangeable mouthpiece to attach, which allows for the user to hold onto it with just the edge of their teeth. The issue with our mouthpiece is that it has not been treated for safe human use. For this reason, we were unable to send an unfinished product to our client without properly testing it. After testing the blow switch, it was clear that this design was superior in performance and durability. Below are both of our prototype demonstrations. The first demonstration is for the blow switch. As can be seen, a simple puff of air will shutter the camera for a single photo or multi-sport photo take. Our second demonstration is for our bite switch device. The bite switch will shutter for single and multi-photos as well, but it only requires a small pressure onto the bite switch itself.
One of the stretch goals for our project was to find a way for Gary to control the zoom feature of the camera. Since we can't control the zoom feature with the audio jack, we had to find another way. While meeting with Gary, we noticed he has attachments on his mount mover that allow him to slide material between his fingers and act as a handle. These allow him different movements for the physical position of his camera. As a result, we decided to use a joystick with a similar attachment and a servo motor to rotate the zoom switch. We planned on using a rapid prototyping and redesign approach to design the servo mount and arm, but due to the resource and time limitations of the COVID-19 pandemic, we were unable to complete the Zoom portion. Despite this, we have working code and a prototype mount for the camera.
The two major tests that were completed include the waterproof testing of the bite switch and the durability testing of the blow switch. The bite switch was waterproof tested to ensure the material would be safe and functionable within the mouth. The blow switch was durability tested by continuously moving the switch around while continuing to take pictures. The switch was verified to work under various moving conditions and met the target specifications for durability and material. As seen on the slide, the total cost of the components is around $245 per unit. The complete bill of materials can be seen as well. This number is a bit misleading, however, because it sums the cost of every component on the bill of materials list. However, this bill of materials list includes all the components needed to complete both versions of the prototype. This total cost includes the components for the optional zoom control functionality. Therefore, the total cost to complete the most basic single unit would actually be somewhat lower. It is also worth noting that anything labeled "See above" indicates that it is included in the cost of the 3D printing plastic order.
Finally, in terms of recommended design changes, there are two major areas we think could be improved if this project were to continue in the future. The first one being an improvement of the cases. Currently, all the casings are 3D printed and as such are not extremely durable. Furthermore, our current method for mounting is via Velcro strips. Improvements could be made to make both cases and the mounting more durable and secure. The second area of improvement has to do with the fact that our current prototype has many wires that are easy to get tangled up. One improvement could be reducing the number of wires. We once investigated controlling the zoom lens over Wi-Fi connectivity through the Panasonic app. However, this was deemed too ambitious at the time. If this project were to be continued, those are some improvements that could be made.
In summary, this presentation should have demonstrated that our product has met all functional requirements, cost goals, and of course, customer needs. Our video presentations showcased both the blow switch and bite switch are capable of triggering the shutter to take a photo. Furthermore, our cost analysis shows that all versions of our prototype are well under the $1,500 budget. Finally, we are glad to report that all of our customer needs have been met, and we are fortunate enough to have enough time to begin implementing additional functionality in the form of zoom control. On behalf of Team B23, thank you for listening.